As a part of this class, let's talk about the singleton design pattern. The singleton pattern happens to be one which is the most commonly used in my opinion. If you've ever written any Java code for any number of years, you would have used the singleton pattern. A lot of basic code requires the singleton. Now, what is a singleton? It's exactly what the name says. A singleton essentially is one instance of a class object which should be used across your code. The single instance is called the singleton. Why would you have one instance of a class object and why would you need it? There can be a whole variety of reasons. Perhaps the object is very hard to instantiate it. It's very performance heavy because it's reading in a bunch of files or something. Maybe it takes up a lot of memory and you don't want to have multiple instances. Maybe it's doing a very specific task for which there should be just one connection for a database or something. These are all cases where you use a singleton. Now let's look in some detail as to what a singleton is when we'd use the singleton pattern. For something which has such a simple explanation, setting up a singleton is surprisingly hard. So as a part of this class, you'll see examples of singletons and the pitfalls that you'll have to avoid. So, what is a singleton? We've answered this in brief. Let's take a look in some detail as to what it is. Now, you'll often find situations while you're programming where exactly one object of a particular type is needed. You don't want multiple instances. In fact, you want to programmatically enforce that only one object of a particular type can ever be instantiated. It would in fact be bad to have more than one object of a particular class. That is where you'd use a singleton. What are examples where it would be bad to have more than one object of a class? Device drivers, registry setting managers, or other system-wide shared objects are classic examples where you'd use a singleton to interface with these. You don't want multiple registry setting managers and having a program in different portions of its code overwriting one setting with another. Singleton objects also make sense where the state of an object can consume a lot of memory. On any machine, you have a limited amount of memory where your program can run. And if a program consumes a lot of memory, it can just crash. Maybe singleton objects take up a lot of memory and you don't want more than one instance of these. If your object consumes a lot of memory and just one version of that state is sufficient for the entire application, that's when you'd use a singleton. So here are a whole bunch of examples, but there could be more. So in such situations, a standard and a widely used way of achieving this one instance of an object or one instance of a class paradigm is the singleton pattern. Now, in order to create a singleton and use this design pattern as a part of your code, what does it need to satisfy? A singleton object must satisfy two attributes. Exactly one, in fact, at most one instance of the object should exist. You should be able to programmatically enforce that only one instance of this object is ever created across your application. Now that we have just one instance, anywhere in your code, you should be able to access that one singleton object. Everyone should be given access to that object. What does this imply? Now it turns out that the first attribute is surprisingly difficult to guarantee in code. In fact, you'll find as we look at the example that a lot of our effort goes into guaranteeing that exactly one object is instantiated of a singleton. This is a hard problem and there are a multitude of ways by which we can fix this or tackle this. The point 2 means that the object needs to be globally accessible. You should have some way of exposing that one singleton object to any code which requests it. Both of these conditions need to be satisfied so that you can use a singleton successfully in your code. Let's see what code looks like to create a singleton. Take a look at the code which is on your screen. You have a public class named Singleton, and it has a whole bunch of methods in it. Just take a moment, look at what's on your screen, and then we'll talk about each of this in turn. So we have a singleton member variable which is static and of type singleton and is private. We have a private constructor. We haven't seen that before, but we'll talk about it. And we have a get instance which creates an instance of singleton if one didn't already exist. And the access to that is synchronized. Now let's see each of these in turn. We'll start with the private constructor. This is the first time we've probably seen this. The constructor of a singleton must be private. This allows us to enforce that nobody outside the singleton class can instantiate the singleton. Effectively, by making the constructor private, the singleton class itself becomes a gatekeeper for instantiating this object. No one outside can write code like this, new singleton, to instantiate the singleton class. It can only be done by code within this class. Alright, let's look at the get instance, which actually instantiates a singleton. It's a static getter method. It instantiates the singleton only the first time it's called. So you see the check for singleton equal to null? It's done at all points in time. If an instance of singleton exists, it will not create a new one. It simply returns the singleton which existed before. This is how you create a singleton. Then we have a static private member variable to hold the singleton. It's static because it has a static get instance, which is why the member variable also needs to be static. Now, synchronized get instance. The synchronized keyword on the get instance is very, very important. The whole idea of the singleton is that it's used in a huge application which has multiple threads running. You do not want to allow two threads to create their own instances of singleton. If you allow only one thread to enter get instance at any point in time, you'll kind of be able to guarantee that you'll have only one instance of singleton. That is why synchronizing the access to get instance to allow only one thread to enter at any point in time is extremely important.